Hello, Physics 1 students and other randos from the internet. We're on to the third section, the analysis section. So the first thing that we want to do is we want to go to the graphing section and we want to get our original equation. So the way that I'm going to do that is I am going to highlight my equation, hit Control C, and then I am going to come over to the analysis section and hit Control V. Then for the other equation, I'm going to go to the other graph, and I'm going to select the trend line from that graph, copy it by hitting Control C, and paste by hitting Control V. So if you're OCD like I am, you probably noticed that I lost my borders on these two boxes. So this is actually a really great teaching moment here. So what I'm going to do is I'm going to highlight all of my cells, click the home button, and then this little drop down menu controls your borders. So I want all borders. So I select all borders, and now you can see I have all of my borders back. So the next thing that we're going to do is we're going to write in the corrected equation. And so by corrected equation, I mean we're going to put in d and t for y and x, but we're also going to round it off to the correct number of decimal places. So for the d versus t, we know that when we graph, it's always y versus x. So we know that y is going to be d now, and that x is going to be t now. But as far as rounding, we need to look back at our original data, because our original data is going to tell us what the precision of our measuring device was. So this right here, these two columns, these were our original data, and you can see that they don't come out any farther than the 10th place. So that means when we do our analysis section and we correct our equation, this corrected equation should also not exceed the 10th place. So for this, it's going to be d is equal to a negative 0.3 t plus 6.4. And that's it. Then for graph number 2, well, once again, this is y versus x, so we're actually going to switch this now. Y is going to be t, and x is going to be d. And so when we write in our equation, we have t is equal to a negative 3.3 d plus 21.4. All right, and that's it. So then we can move on to the next row, which is slope. And so hopefully everybody's familiar with slope. When we do y is equal to mx plus b, slope is m. So that's going to be your coefficient in front of your t term here and in front of your d term here. Okay, so this is going to be negative 0.3 and this is going to be negative 3.3. Units of slope, well, you just have to look up here. We know y versus x, so this is associated with our x variable, right? So time, the unit for time is seconds. We can double check that if we look back over at the data entry, confirm that it is indeed seconds, not minutes, hours, etc. So we have confirmed it is indeed seconds. Okay, then for graph 2, that's going to be d this time, right? D. And that is going to be meters. And if we wanted to confirm that, again, we could go back to our data entry section and confirm that indeed it is meters and not, maybe inches. Maybe we went with the imperial system because, this is America. All right, so y-intercept, of course, that's just the b term, right? In y is equal to mx plus b. So that's going to be your constant over here and over here. So that's going to be 6.4 and 21.4. And then units of y-intercept, well, it stands to reason since it's a y variable, of course, it should have the same units as y, right? So y versus x, that's d here, so that's going to be meters. And that's t here, so that's going to be seconds. And that's pretty much it. Now you're done with the analysis section, and there is only one more section to do, trigonometry.